Hi all, very happy morning, happy afternoon, happy evening from Anil Nair classes. My name is Anil Nair. Today I will be discussing a fundamental concept from number system. Today's class is extremely important for all the students who lack some basic concepts before we solve high level questions from number system. Today I will be discussing few important topics, that is all the problems related to squares, all the problems related to perfect squares, all the problems related to cubes, how to find the cube of a number, how to find the cube of a number nearer to 10 power k, how to find the cube root of a perfect cube, and some advanced level problems related to all these four concepts. All these four concepts which we are going to discuss. Maximum problem solving will be there on related to this concept, so that you will understand where to apply these concepts. I hope you are all ready. Let us straight away get into the problems. Now, concept 1. Concepts. First one, a perfect square never ends with. A perfect square never ends with 2, 3, 7 or 8. If a number is a perfect square, it will never end with 2, 3, 7 or 8. Let us see the proof. If a number is a perfect square, it will never end with 2, 3, 7 or 8. Let me take the unit digit of a number. Unit digit of a number will be from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I square 0, 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9, 4 square unit digit is, 4 square value is 16, unit digit is 6. 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81. What are all these? These are nothing but the unit digit of the squares. Again I am explaining, if a number is a perfect square, it will never end with 2, 3, 7 or 8. A unit digit can be from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I square it, 0 square 0, 1 square 1, 2 square 4, 3 square 9, 4 square 16, 6, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81. A perfect square, if a number is a perfect square, it will never end with 2, 3, 7 or 8. For example, is 5, 5, 4, 3, 2 a perfect square? Is 5, 4, 3, 2 a perfect square? Answer will be no, because a perfect square will never end with 2, 3, 7 or 8. I hope idea is clear. Is 1, 2, 3, 4, 5, 6, 7, 8. Is 1, 2, 3, 4, 5, 6, 7, 8 a perfect square? A perfect square never ends with 2, 3, 7 or 8. Therefore the answer is no. First concept is based on a perfect square. A perfect square never ends with 2, 3, 7 or 8. A simple applications, once we do problems, you will understand it how to use it. Second concept. Every perfect square has a digital sum. Every perfect square has a digital sum 1, 4, 7 or 9. If a number is a perfect square, it will have digital sum 1, 4, 7 or 9. Right? Reverse may or may not be true. Reverse may or may not be a true. That means, if a number is a perfect square, it should definitely have digital sum 1, 4, 7 or 9. If that number has a digital sum 1, 4, 7 or 9, it may or may not be a perfect square. Proof. Suppose if I take 1, 2, 3, 4, the digital sum of these number is nothing but the sum of the digits until you get a single digit number. 4 plus 3, 7, 7 plus 2, 9, 9 plus 1, 10. 10 is nothing but 1. That is the definition. Digital sum is nothing but the sum of the digits. Digital sum is nothing but the sum of the digits till you get a single digit number. Till you get a single digit number. Digital sum is nothing but the sum of the digits till you get a single digit number. What are all the single digits that are possible? From 0 to 9. 0 is not possible. If you add the digits, why will you get 0? If a digital sum is nothing but the sum of the digits till you get a single digit number. What are all the single digits possible from 0 to 9? 0 is not possible. Why? Because if you add the digits, getting 0 is illogical. So I will take all the digital sums that are possible. All the possible digital sums are 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 is not possible. What is 1? Suppose 91 is there. 9 plus 1 is a 10. 10 digital sum is 1. Suppose if 181 is there, 181 digital sum is again 1. So these not 1, these the set of all numbers whose digital sum is 1. 1 square 1, 2 square 4, 3 square 9, 4 square 16, 16 digital sum is 7, 5 square 25, 2 plus 5 7, 6 square 36, 3 plus 6 9, 7 square 49, 4 plus 9 13, 4, 8 square 64 which is nothing but 1, 9 square 81, 8 plus 1 is nothing but 9. If you observe what are all the values that you got in the right hand side? 1, 4, 9 or 7. 1, 4, 9 or 7, and left hand side all the possible digital sums are squared. So every perfect square will have digital sum 1, 4, 7 or 9. If a number is a perfect square, it will have digital sum 1, 4, 7 or 9. But the reverse case, if a number has got digital sum 1, 4, 7 or 9, it may or may not be a perfect square. It may or may not be a perfect square. For example, if you take is 1, 2, 3, 2, 1, is 1, 2, 3, 2, 1 a perfect square? Is 1, 2, 3, 2, 1 a perfect square? Now if you see what is the digital sum of this number? 3 plus 3 6, 6 plus 2 8, 8 plus 1 9, 1 plus 2 is 3. If a number is a perfect square, it should have digital sum what? 1, 4, 7 or 9. What is the digital sum I got? 3. Can it be a perfect square? No. So answer for this question is no. I hope it is clear. Suppose for example, is 13 a perfect square? 13, what is the digital sum? 13 digital sum is 4. But is 13 a perfect square? 13 is not a perfect square because 13 is ending with 3. If a number is a perfect square, it should never end with 2, 3, 7 or 8. Always remember, if a number is a perfect square, it will have digital sum 1, 4, 7 or 9. If a number has got digital sum 1, 4, 7 or 9, it may or may not be perfect square. I hope it is clear. It may or may not be a perfect square. This is the second concept. This is the second concept. This is the second concept. I hope the idea is clear. Now we will get into a problem solving. Please read this question once. Each member of a picnic party contributed twice as many rupees as the total number of members. Method 1. Method 1. There are total number of members. There are total number of members. Let me call it as P. Okay. What is happening? Each member contributed twice as many rupees as the total number of members. So contribution is nothing but number of members are P. Each one contributed twice as many rupees as the total number of members. This contribution is nothing but twice the total number of members. So total contribution is nothing but 3042. So these nothing but 2p square equivalent to 3042. These is nothing but p square equivalent to 1521. P square equivalent to 1521. 1521 is an odd number. Odd number on square should be an odd number. P should be an odd number. P should be an odd number. P, here it is an even number, here it is an even number, here it is an even number. So answer for this question is 39. So 39 whole square is nothing but 1521. Eliminating first three options, I got this answer. This is a traditional method. Now you might get a doubt, what if instead of 39, 29 is there? What if instead of 39 some other odd number is there? That also we will do it. So p square is 1521, p value is 39. Another idea is how you can find it out 39 whole square as 1521. That also we will discuss. First method, I hope it is clear, right? Now, right, concepts. Now see here, what we got, 2p into p is nothing but 3042. So p is nothing but, p square is nothing but 1521. How to find out the value? Suppose I said that 39 is the answer. Why 39 is the answer? Square of the numbers from 35 to 75. Listen carefully. Square of the numbers from 35 to 75. 50 plus x whole square equivalent to 25 plus x slash x square. X square should be a 2-digit format. X square should be a 2-digit format. Suppose if I take 39 whole square. 39 whole square is nothing but 50 minus 11 whole square. X value is minus 11. 25 minus 11 slash minus 11 square. 25 minus 11 is 14. 11 square is 121. Write down the last two digits. 21. 1 carried. 14 plus 1 is 50. So 39 whole square is 1521. I hope the idea is clear. 39 whole square is 1521. You can also take one more example just to understand the concept. Suppose if it is 48 square. 48 lies from 35 to 75. So this is 50 minus 2 whole square. X is minus 2. 25 minus 2 slash minus 2 square. So it is nothing but 25 minus 2 is 23. 2 square is 4. 4 in a 2-digit format is nothing but 04. I hope the idea is clear, right? P square equivalent to 1521. We have found out which value on squaring I will get 1521. This is by using square logic. Now I will explain the square root logic. I hope the idea is clear, right? P square is 1521. You can use this logic to find the squares from 35 to 75. 50 plus x whole square is nothing but 25 plus x slash x square. 50 plus x whole square is nothing but 25 plus x slash x square. Another concept. Suppose if it is, where are we? 2p square equivalent to 3042. So p square is nothing but 1521. Now p is nothing but square root of 1521. Another concept. How to find the square root of perfect square? How to find the square root of perfect square? First one, square root of 1521. Square root of 1521. Square root of 1521. Because it is a perfect square, start from the rightmost. Keep a slash after 2 digits. Keep a slash after 2 digits. Which number on square I will get 1? 1 square on square is 1. 9 square on square is 81. There are two possibilities, 1 or 9. 15 lies between which two squares? 3 square is 9 and 4 square is 16. 3 square is 9, 4 square is 16. So take the lowest value. Answer is either 31 or 39. Answer is either 31 or 39. But if you take 35 into 35, 5 5s are 25, add 1 to it. 3 plus 1 is 4. 4 3s are 12. 1521 is greater than 1225. So answer has to be 39. So square root of 1521 is nothing but 39. Idea clear? Again I am explaining. If I want to find out the square root of a perfect square, square root of 1521, keep a slash after 2 digits because it is a perfect square. Square number is ending with 1. So 1 square is 1 or 9 square is 81. 15 lies between which two squares? 3 square is 9 and 4 square is 16. So it will be 31 or 39. Here I am using a logic how to find the squares of a number ending with 5, which I have already discussed in one of my old shortcut videos present in our YouTube channel. You can see it. 35 into 35 is 5 5s are 25, add 1, 4 3 are 12, 1 2 2 5. 1521 is greater than 1225. So answer has to be 39. Let us take one more example. Suppose if it is square root of 3969. 3969. Keep a slash after 2 digits. 9 means 3 square 9, 7 square 49. So 6 square is 36, 7 square is 49. 6 square is 36, 7 square is 49. It will be either 63 or 67. But if you see 65 into 65, 5 5s are 25, add 1, 7 6 are 42, 4 2 2 5. So the here answer is nothing but 65 whole square is 4225. 63 square is 3969. So answer is nothing but 63. I hope the idea is clear. First one, we have discussed so many logic. Odd number on square is an odd number, that is the first logic. How to find the square of a number from 35 to 75 is the second logic. How to find out the square root of a perfect square. Still I will discuss more and more problems as I proceed. I hope the first one is clear. Second one, see the question. Second one, 1008 divided by which single digit gives me a perfect square? Method 1. There is a number 1008. 1008 is divided by which single digit number which gives you a perfect square. Which gives you a perfect square. Which gives you a perfect square. So if I use options method, first one, 1008 divided by 9, which is nothing but 9 11s are 99, which is 112. 112 is not a perfect square. 112 is not a perfect square. Why? Because a perfect square never ends with 2, 3, 7 or 8. Suppose if it is 1008 divided by 4, which is nothing but 252. 252 is also not a perfect square. Third one, 1008 divided by 8. 8 12s are 96. 48, 8 6 are. So it is nothing but 126, which is not a perfect square. Why? Because 126, 11 square 121, 12 square 144. 1008 divided by 7, which is nothing but 144. 144 is nothing but a perfect square. 144 is nothing but a perfect square. Are you all with me? So one is by using options. Easily you can check it out that 144 is nothing but a perfect square. 144 is nothing but a perfect square. What is the logic that is used here? A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. Are you all with me? A perfect square never ends with 2, 3, 7 or 8. Now just I hope the idea is clear, right? So first option out, second option out, third option out, fourth option, 144 will be the answer. Now if you see, just by observation, method 2, just by sheer observation. Now if you see here, 1008 divided by 4 if I take, right? Divisibility rule of 4 is, divisibility rule of 4, divisibility rule of 4 is nothing but the last two digits, last two digits, last two digits. Divisibility of 4 is nothing but the last two digits. So 8 divided by 4, it will become 2. A perfect square never ends with 2, 3, 7 or 8. Are you all with me? A perfect square never ends with 2, 3, 7 or 8. Now suppose this is the first observation. Second observation, 1008 divided by P is nothing but K square. Am I right? So P into K square is nothing but 1008. P into K square is nothing but 1008. K square is a perfect square. K square is a perfect square. Every perfect square will have digital sum. Will have digital sum 1, 4, 7 or 9. 1, 4, 7 or 9. 1, 4, 7 or 9. Now if you see here, P, first option 9. 9 into 1, 4, 7, 9. 9 into 1, 4, 7, 9 may be possible. Second option, 4 into 1, 4, 7, 9. 4 into 1, 4, 7, 9. Answer is nothing but, right? It is also possible. So this logic may not be the best logic. Why? Because one of the possible digital sums is 9. 9 into any number, 9 into any number will give you the digital sum. Or you can go by, right? So we are getting almost all the options same. So try not to use this logic. So what you do is, P into perfect square never ends with 2, 3, 7 or 8. You use this logic. A perfect square never ends with 2, 3, 7 or 8, equivalent to 1008. Check it out with the option, right? 4, is it giving me 8 at the end? 4 2s are 8. So second option is not possible. Is 9 giving me 8 at the end? 9 2s are 18. This is also not possible at the end. Is 8 giving you any possibility? 8 2s are 16, 8 3s are 24, 8 7s are 56, right? 8 8s are 64. It is not giving me. That means through sheer observation, these two logics are out. Answer could be this or this, which you can check it out. So method 2, try not to use this method unless and until the numbers are big and you are able to eliminate the logic because of perfect square logics. A perfect square never ends with 2, 3, 7 or 8. Every perfect square has a digital sum 1, 4, 7 or 9. By using these two, if you can eliminate few answer options, go to method 2, otherwise go by the method 1. I hope it is clear. I just tried to use the divisibility rule of 4 and this logic. This perfect square has a digital sum. A perfect square has a digital sum 1, 4, 7 or 9 is not working effectively here because the right hand side digital sum is 9, right? 9. So any number multiplied by 9 will automatically give you digital sum 9. I hope the logic is clear. Method 3. Method 3. By which smallest number 5808, let us check in this logic anything will work, should be multiplied so that it becomes a perfect square. So that it becomes a perfect square. A perfect square. What are all the logics? A perfect square. A perfect square never ends with. A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. That is one logic. Next one, every perfect square, the digital sum of a perfect square, should always be 1, 4, 7 or 9. A digital sum of a perfect square should always be 1, 4, 7 or 9. I will use any of these logic to get the answer. Suppose if you see first option 5808 into 2. Let us see the digital sum. 5 plus 8 13, 13 plus 8 21, 21 is 2 plus 1 3, 3 into 2, 3 into 2 is 6. A perfect square should always have digital sum 1, 4, 7 or 9. These out. Second option 5808 into 7. So these digital sum is 3. 3 into 7. 3 sevens are 21. 2 plus 1, 3. A perfect square should have digital sum 1, 4, 7 or 9. Right? Third option. Right? 5808 into 11. These is nothing but 3 into 11 is 2, which is 6. A perfect square should have digital sum 1, 4, 7 or 9. So answer is 3. That means in the third problem, you are able to use the logic of a perfect square should have digital sum 1, 4, 7 or 9. If you observe previous problem, it is not the effective method, but in this problem, this is the effective method. This is the method 1 based upon the concept of every perfect square should have digital sum, should always be 1, 4, 7 or 9. I hope idea is clear. One more idea also we can do it. Method 1. Just my idea is to give you different ways of solving a question. It depends upon your practice which method to solve. Method 2. Suppose if the question is 5808 into P, it should be a perfect square. Generally most of the students, how they solve this question is, they will factorize it. Let me factorize it. 2 into 294, 04 into P is A square. 2 into, suppose if I do 2 into 1452 into P is nothing but A square. So 2 square into, this is nothing but 2 into 726 into P is nothing but A square. So 2 cube into, this is nothing but 6 into 121 into P is nothing but P square. This is nothing but 2 cube into 2 into 3 into 11 square into P is nothing but P square. 2 power 4 is a perfect square. 11 square is a perfect square. 1 3 is there, another 3 should be there. So what is the answer for this question? 3. Check it out. You have to find out the factors of 5808 and check which factor does not have a power even number, then you have to solve it. This is the traditional method where most of the students will solve it, but if you know the logic that a perfect square always has a digital sum 1, 4, 7 or 9, you can save your time, you can save the number of steps. That is why you should regularly follow ANC YouTube channel to solve aptitude problems through a prism never seen before. I hope the idea is clear. Next one, which one of the following numbers is not a square of a natural number? Something is not a square of a natural number. Now let us see. What are the logics? A perfect square. A perfect square, what are the two important concepts? A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. A perfect square digital sum, a perfect square digital sum will always be, a perfect square digital sum will always be 1, 4, 7 or 9. 1, 4, 7 or 9. Any of these two logics we will check it out. A perfect square never ends with 2, 3, 7 or 8. First option 1, 7, 9, 5, 6. Let us use the digital sum. 9 is eliminated. 6 plus 5, 11, 11 plus 7, 18, 18 plus 1, 19. 19 digital sum is 1. This could be the possibility. Second one, 18225. 9 plus 9, 18. 9 plus 9, 18. Digital sum 9. This could be the possibility. Right? Third one, 53361. Digital sum 6 plus 3, 9. 9. This could be the possibility. That means based upon this logic, only one number we are able to eliminate. Only one number we are able to eliminate. Right? So therefore, we will use another logic. Which of the following is not a perfect square of any natural number? We will use another logic. Now what is that logic? First one, 17956. 17956. Now see here. This is nothing but square root of 17956. Right? Because it is square root. Keep a slash after 2 digits. If I keep a slash after 2 digits, I got answer will have 4 at the end. 4 square is 16 or 6 square is 36. 179 lies between which two perfect squares? 13 square is 169, 13 square is 169 and 14 square is 196. So answer will be either 134 or 136. Answer will be either 134 or 136. Suppose if I take 135 into 135, 135 into 135, 5 5s are 25, 13 if I add 1, 14 13s are 14 3s are 42, 18225, 17956 is less than 18225, 18225. So answer for the first one is, this is nothing but the square of 134. 134. Now let me check for the second option. What is second option? Already we got 18225. Second option value is 135. So this is a square, this is a square, this is not a square. So answer for this question is 53361. Answer for this question is 53361. If you want to solve also, you can solve. Square root of 53361 is, keep a slash after two digits. 1 square is 1 and 9 square is 81. 533. 533 means where it will be. 21 square 441. 22 square 484. 23 square 529. So 231 and 239. 231 and 239. You can check it out if the digital sum is matching and everything. Suppose 231 whole square. 235 let us do. 235 into 235 will be 5 5s are 25. 5 5s are 25. 23 into, I think why we are doing all this, which of the following is not a square? Not a square means only one logic, right? Right? 63592. We are unnecessarily wasting our time doing this. Anyway, all the three we are trying to prove that they are perfect squares. So 23 into 24. 24 3s are 72. 2. 48. 48. 552. 552. So 235 whole square is 552, but I want 533. So answer for this question is 231. This is a square, this is a square and this is a square. C is not a square. Directly you can tell that 63592 is the answer, because a perfect square never ends with 2, 3, 7 or 8. Instead of telling that C is right, I try to tell you that all the other three are perfect squares. What if the option contains one more option, how to do it? I hope the logic is clear. Next one, the least number which is a perfect square, the least number which is a perfect square and is divisible by 16, 20 and 24. Now there are two conditions. N should be smallest. N should be smallest. It should be a perfect square. It should be a perfect square and it should be divisible by 16, 20 and 24. 16, 20 and 24. What is the number that is divisible by 16, 20 and 24? LCM of 16, 20 and 24. I hope it is clear. LCM of 16, 20 and 24. First one, it should be a perfect square. Perfect square digital sum. A perfect square digital sum should be 1, 4, 7 or 9. A perfect square digital sum should be perfect 1, 4, 7 or 9. This is 7, this is 9, this is 1 and it is 9. All the options are satisfied. Now it should be LCM of 16, 20 and 24. 16, 20 and 24. Now let us do one by one. 16 with 20. 20 is not divisible by 16. What is the next multiple? 40. 40 is not divisible by 16. 60 is not divisible by 16. 80 is divisible by 16. So for this one, multiple I got is 80. So one is 24 and another is 80. One is 24, another is 80. First two multiple I got common is 80. 80 is not 80 and 24. You can do it in multiple ways. So what we'll do is, so this is nothing but, suppose for example, this is 4 into 6. Here it is nothing but 4 into 20. Here we can write it as 8 into 3. And here it is nothing but 8 into 10. 8 is common, take it out. 3 and 10 are co-prime numbers. LCM of co-prime numbers. LCM of co-prime numbers is always a product. LCM of co-prime numbers is always a product. 3 tens are 30. So answer for this question is 240. It should be divisible by 240. It should be divisible by 240 and it should be a perfect square. It should be divisible by 240 and it should be a perfect square. Let us see, check which number it is divisible by 240. Suppose if I take 1600, 1600 is divisible by 240, 160 is not divisible by 24. If I take 6400 divided by 240, 640, 24 2s are 48, 160 it is not divisible. So this is out and it is out. We are stuck between 3600 and 14400. Now if you see 3600 is divisible by 240, 24 ones are 24, it is 15. This is also 14400, it is also divisible by 240. Now check it out. Which one is the question is the smallest number. Smallest number is nothing but among these four, 3600. Smallest number, it is nothing but 3600. This is the generic way. Best way is to check whether answer options are divisible by 16, 20 and 24. Now if you observe 1600 is divisible by 16. 1600 is divisible by 20. 1600 is divisible by 24. 24 6 are 144, 160. 1600 is not divisible by 24. So first option is out. Third option 6400. 16 it is divisible. 20 it is divisible. 24 you can check it out. Similarly you can check by using answer options. I hope the idea is clear. These 3600 should be divisible by 16, 20, 24 and it should be a perfect square because it's a smallest number, that itself is the answer because it is 60 whole square. Product of two positive numbers is, next one, product of two positive numbers. A is one number, B is another number. Product of two positive numbers is 2500. If one number is 4 times the other number, so it is nothing but 4b square equivalent to 2500. So b square is nothing but 625. So b is nothing but square root of 625, which is nothing but 25. Which is nothing but 25. I hope the idea is clear. You can check by using the digital sum logic also. You can check by using digital sum logic. Suppose if the question is square root of 625 equivalent to 25. Remove the square root. 625 equivalent to 25 whole square. 6 plus 2 8, 8 plus 5 13. 13 is 4. 2 plus 5 7, 7 square is 14 9. 4 plus 9 13, 1 plus 3 4. 4 equivalent to 4, it is matching. Square root of 625 equivalent to 125. 625 equivalent to 125 whole square. 8, 5 plus 2 7, 7 plus 6 13, which is 4. 7, 5 plus 2 7, 7 plus 1 8, 8 square is 64, 6 plus 4 10, 1. 4 is not equivalent to 1. Similarly, you can use answer options also, you can do it. Square root of 625 cannot be 125. If 125 is not the square root of 625, how come 225 and 250 will be the option? I hope it is clear. Directly you can eliminate 250 because in square root it is 5. Which number on square I will get 5 at the end? 5 square is 25. So 0 is eliminated. 0 is eliminated. I hope the idea is clear. Next one, 1 square plus 2 square plus 3 square, 1 square plus 2 square plus 3 square, and so on up to 20 square is 2870. The question is 2 square plus 4 square plus 6 square, and so on up to 40 square. So if I take 2 square common, this will be 1 square plus 2 square plus 3 square, and so on up to 20 square. This is nothing but 4 into this number is 2870. 4 into something. Answer should be divisible by 4. So 2870 it is out. So 4 into 2870. You can use a digital sum concept here. If I use a digital sum concept here, 4 into 2 plus 8, 10, 1. 1 plus 7, 8. 4 8s are 32. 3 plus 2 should be 5. 3 plus 2 should be 5. This seems to be giving you 5 option. 12 plus 4, 16, it is 7. 7 plus 2, 9, it is not the answer. So answer for this question is 11480. You don't need to solve these multiplication to prove something. Not at all required. I hope the idea is clear. 4 into 2870. So 2870. 2 plus 8, 10. 10 plus 7, 17. 1 plus 10 plus 7, 17. 17 digital sum is 8. 4 8s are 32. 3 plus 2, 5. Idea is clear, right? Next one. Divisibility rule of 4 applied. Suppose if the next logic 1 cube plus 2 cube plus 3 cube and so on up to 10 cube. These are nothing but 3025. Suppose if I take 2 cube common, these are nothing but 1 cube plus 2 cube plus 3 cube and so on up to 10 cube. So these are nothing but 8 into 3025. 8 into 3025. Answer should be divisible by 8. If answer is divisible by 8, it should be divisible by 4. Right? Any number divisible by 8 should also be divisible by 4. This is out, this is out. 8 into 3000 only. 8 into 3000 only will give you 24,000. Answer should be just greater than 24,000. This is there. I hope it is clear. Answer for this question is 24,200. Answer for this question is 24,200. Next one. 32 cube plus 79 cube minus 111 cube plus 3abc. Now if you see here, note a plus b plus c is 0. If a plus b plus c is 0, a cube plus b cube plus c cube is 3abc. A plus b plus c is 0. A cube plus b cube plus c cube is 3abc. So 32 cube plus 79 cube plus minus 111 whole cube is 0. So it is nothing but 32 plus 17 minus 111. So answer is nothing but 0. Right? So a cube plus b cube plus c cube minus 3abc is 0. If I use this, 32 cube plus 79 cube, c cube is minus 111 whole cube minus 3 into 32 into 79 into minus 111. These are nothing but 0. Answer should be 0. Answer should be 0. Answer should be 0. I hope it is clear. This is one way of solving the question based upon the identity a plus b plus c is 0. If a plus b plus c is 0, a cube plus b cube plus c cube is 3abc. Again I am explaining. If a plus b plus c is 0, a cube plus b cube plus c cube is 3abc. This is one way to solve. Another way to solve, just by looking at the question only, we are able to eliminate few answer options. 32 is an even number. Even number on cube is even. This is an odd number. 111 is an odd number. 32 is even. Even into anything even. Even plus odd is odd. Even minus odd is odd. What is odd plus odd? Odd plus odd should be an even number. Should be an even number. So this is out, this is out. Just by using the concept of even number and odd number, you can derive two options where the answer options are odd. So 1 and 2, it is out. Then what you can do is, you can apply digital sum. You can apply digital sum logic, right? Not only this identity, high calculations also you can do it. 3 plus 2, 5. 5 cube is 125. 125 digital sum is 8. 79. 7 plus 9, 16, which is 7. 7 cube is 343, which is 1. Minus triple 1 is 1 plus 1 plus 1, 3. 3 cube is 27, which is 9. Plus 3 into 32 into 5, 79. 7 plus 9, 16, 7. Triple 1 is 3. 3 into 3, 9. This entire thing is cancelled. Answer digital sum should be 0. Answer digital sum should be 0. Only one option digital sum is 0. Only one option digital sum is 0. I hope the idea is clear. I hope the idea is clear. Multiple ways of looking at a question. Instead of just solving the question, you will understand a lot of ideas when to use that idea, whether the idea is working or not. If it is not working, is it because of answer options, right? Then we will go into the next idea. Next one, 53 into 87 plus 159 into 21 plus 106 into 25. All the answer options unit digit is 0. All the answer options unit digit is 0. That means we should not play with the unit digit logic. All the answer options digital sum is 7. So digital sum, even if I use, or unit digit if I use, it will backfire. Now let us see how to. 53 into 87. 159 is nothing but 53 into 3 into 21. 106 is nothing but 53 into 2 into 25. So if I take 53 common, these 87 plus 63 plus 50. So this is nothing but 53 into 150 plus 50, which is nothing but 53 into 200. So answer is nothing but 10600. 10600. So answer for this question is 10600. I hope the idea is clear. I hope the idea is clear. I will not use unit digit logic here. I will not use unit digit logic here. I will not use digital sum logic here. I will not use any of these logic here. Unit digit logic I will not use, and digital sum logic also I will not use. I hope the idea is clear. Next one. Number of digits in the square root of 62478078. Now we will discuss a concept of how to find out the number of digits in the square root of a number. Number of digits in the square root of a number. Number of digits in the square root of a number. Two examples I will do, then it will be clear. Suppose if it is 12544, square root of 12544. Step number 1, start from the rightmost, keep a slash after every 2 digits. Start from the rightmost, keep a slash after every 2 digits. Take a group of 2 digits. One group, another group, one can be written as 0, 1. So how many answers are there? How many digits are there in the answer? There are total 3 digits in the answer. Start from the rightmost, take a group of 2 digits. Take a group of 2 digits. Every 2 digits group is nothing but 1 digit. Every 2 digit group is nothing but 1 digit. Suppose if it is 984064. 984064. Square slash slash slash. Answer contains how many digits? Answer contains 3 digits. Answer contains 3 digits. I hope it is clear. Suppose if it is square root of 9409. Keep a slash after 2 digits. So answer contains how many digits? Answer contains 2 digits. Idea is clear. Number of digits in the square root of a number. Keep a slash after every 2 digits. Keep a slash after every 2 digits. Now let us solve this question. Square root of 62478078. Keep a slash after every 2 digits. Keep a slash after every 2 digits. Answer contains totally how many digits? Answer contains totally 4 digits. Answer contains totally how many digits? 4 digits. Idea is clear? So answer for this question is 4. Answer for this question is 4. How to find the number of digits in the square root? I hope it is clear. Next one. Find the fourth root of. Fourth root means what I will do is 2401 4 zeros on that one and another square root. First we will find out this one. 4 zeros will become 2 zeros. Square root of 2401. Keep a slash after 2 digits. 1 square is 1 or 9 square is 81. 4 square is 16, 5 square is 25. 41 or 49. So 45 into 45. 5 5s are 25. Add 1. 5 4s are 20. 20. So 45 whole square only is 2025. 45 square only is 2025. 49 whole square will be 2401. So this is nothing but 4900. Again square root. So 2 zeros one will become single zero. 49 answer is 70. 49 answer is 70. I hope the idea is clear. I hope the idea is clear, right? So answer for this question is 70. Next one. Find the digit in the units place of the number. Digits. Two options are missing. The digits in the units place of the number 1570 whole square. 1570 whole square plus 1571 whole square plus 1573 whole square. So this can be written as this is an even number. Even number on square is even. Odd number on square is odd. Odd number on square is odd. This is even. Odd plus odd is even. Answer unit digit should be an even number. Answer unit digit should be an even number. So third option out, fourth option out. By looking at the nature of the number only, we can tell which options are out. Now 1570, 0 square is 0, 1 square is 1, 3 square is 9, 9 plus 1 is 10, unit digit should be 0. Unit digit should be 0. Unit digit should be 0. Answer for this question is 0. I hope the idea is clear. Very easy question if you know the logic. The smallest positive integer when multiplied by 392, the product is a perfect square. The smallest positive integer when multiplied by 392, the product 392 is multiplied by x, which will result in a perfect square. So 392 is nothing but 196 into 2 into x which is nothing but p square. 196 is 14 square into 2 into x is p square. This is already a perfect square. So x should be 2. So x should be 2. I hope it is clear, right? X should be 2. So answer for this question is 2. This is the generic method. Method 2. 392 should be multiplied by which number? And the product is a perfect square. Suppose if I take first option is 6, second option 4, third option 8, fourth option 2. First option if I take 392 into 6, unit digit will become 2. A perfect square never ends with 2, 3, 7 or 8. First option is out. 392 into 4, 2 4s are 8. Perfect square never ends with 2, 3, 7 or 8. I hope the idea is clear, right? 392 into 2. 392 into 2 is nothing but 784. 784 is 28 square. Just by looking at a question only, I can tell this logic. The answer should be 2, or in other words, first option and second option are eliminated because of the perfect square logic. A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. Next question. The smallest number which should be added to the number 8958 so that the result is a perfect square. 8958 plus x. The result should be a perfect square. 8958 plus something, the result should be a perfect square. Options are missing, so I am adding. So if I add 8958 plus first option 169, 169 will become 169. How much it will become? 8 plus 9, 17. 17. A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. This is not possible. This is not possible. This is not possible. If I keep the answer none of this is the answer. Why? Because 8 plus 9 is 17. A perfect square can never end with 2, 3, 7 or 8. Are you all with me, right, sir? Suppose, let us do what should be the number. 8,900 something. What is the perfect square? That is just closer to 8958. Suppose if it is 95 into 95. 95 into 95 is 5 5s are 25. Add 1. 10 9s are 90. So these 9025. 9025 means how much should be added? 8958 plus x is nothing but 9025. So x is nothing but 9025 minus 8958. That means here 40 to 67 should be added. Answer which number? None of this. 67 should be added. 8958. What is the nearest perfect square? What is the nearest perfect square? Closer to 8958. From there you will get the logic. 95 into 95 is 5 5s are 25, 10 9s are 90. 9025. 8958 and 9025, difference is 67. A perfect square never ends with 2, 3, 7 or 8. Largest number of 5 digits which is a perfect square. Largest number of 5 digits which is a perfect square. Now see here. What is step number 1? What is the largest number of 5 digits? Largest number of 5 digits is 5 nines. 5 nines. Am I right? What is the how many digits are there for this number approximately? If it is a perfect square, 1, 2, 3. Am I right? So here it is ending with, so 3 digits are there. 3 digits should be closer to. 3 digits should be closer to this one. Now it should be a perfect square. Perfect square means a digital sum should be. A perfect square should be. Digital sum should be 1, 4, 7 or 9. Am I right? So if I look at first option, 5 nines. 5 nines means any perfect square ending with a 9, tens place should be even. 7 square 49, 13 square 169. So first option is eliminated. D option. D option, let us see. 99764. 99764. 9 plus 9, 18. Digital sum is 9. 7 plus 6, 13. 13 plus 4, 17. 17. Digital sum is 8. So these also is not the option. These also is not the option. I hope it is clear. What will be the nearest perfect square? Right? Nearest perfect square. Now let us see. What we'll do is, what is the smallest value that is closer to 300 and largest number of 5 digits which is a perfect square. We have eliminated first option, 5 nines. It is not a perfect square. Any perfect square ending with 9, tens place should be even. So first option is out. D option, 99764. 99764. Digital sum is 8. Digital sum of a perfect square should be 1, 4, 7 or 9. So first option out, D option out. B and C are not specified. Let us find out the values. Now if you see, let us find the values. Suppose if I assume that, let us find what will be the approximate value. 9999, keep a slash. 999 is nearer to which square? 31 square is 961, 32 square is 1024. So 9 is closer to 3. Let us check what is the value of 315 square. 315 square is nothing but 5 5s are 25, add 1, 31 into 32. 32 1s are 32, 32 3s are 96, 96 plus 3, 90, 32 3s are 96, 96 plus 3, 99. 99. Are you all with me? So 315 into 315, 5 5s are 25, we got 31 into 32, 32 1s are 32, 2 3 carried, 33 3s are 96 plus 3, 99225. 99225. We got 99225. Let me take 316 whole square. 316 whole square. 316 whole square is A is 31, B is 6. 31 square, 2 into 31 into 6 and 6 square. 961, 6 2s are 12, 12 31s are 372 and 6 square is 36. 6 3 carried, 375, 37, 99856. 99856. What I did, I checked the answer option. What is the nearest value that we got? Answer is moving around 313, 314. So I checked the 315 square. 315 square is 99225. So it is, we want the largest number. I checked it out, 316. If 316 square is just closer to the largest number of 5 digits, that itself will be the answer. So answer for this question is 99856. I hope the idea is clear. You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.